Hello guys, my name is Enoch Bereka. I'm a biostatistician and also a data scientist. So today I want to take you through a logistic regression model. So using the diabetes dataset, we want to see how various factors can influence the diabetes outcome. So the first thing in R that you are supposed to do is to load the dataset. And before you load the dataset, you have to install a library called tidyverse. So loading loading necessary libraries. The first one, it is called tidyverse. The other one, it is called PROC. The other one, it is called the other one is GG effects. The other one, it is GT summary for producing tables. GT summary. Yeah, now after loading these packages, we want to load the dataset. Loading the dataset. Today I want us to load the dataset manually. We go to File, then we go to Import Dataset. Our dataset is a CSV, so we use reader to import, then we browse. Then I browse where my dataset is situated. It's called diabetes. Diabetes is my dataset. I open. Then it's loading. After loading, I click import. Now here is my dataset. As you can see, it contains pregnancies, glucose. So after loading the dataset, here is the code. After loading the dataset, we are going to inspect the dataset. The next step is to inspect the dataset. How can we inspect the dataset? Using something like head when you want to see the first 6 observations of the dataset. Here are the 6 observations of the dataset. We can use another one called tail. Tail is used to see the last 6 observations of the dataset. Here are my last 6 observations. We can also do something like structure of the dataset using a function called glimpse. Then glimpse, then the name of your dataset, which is diabetes, then you run. After glimpsing, it gives you this output. The output is saying that our dataset contains 768 rows and 9 columns. It contains 9 variables. One is pregnancy, which is a numeric variable, glucose numeric, blood pressure numeric, skin thickness numeric, insulin numeric, BMI numeric, diabetes pedigree function numeric, age is also a numeric, and as you can see, our diabetes outcome is numeric, but it's supposed to be a factor. So during data preparation, we'll consider converting the outcome into a factor. Then another thing that we want to see is checking for missing values using the function NEMA. Then into bracket the name of the dataset. As you can see, the output is false. It means that our dataset does not have any missing values. Then we check for duplicates, that is sum into bracket duplicated, sum duplicated, then the name of the dataset. Then we run. As you can see, for our output, it is saying that 0 duplicates. It means that our dataset does not have any duplicates. After inspecting the data, the next step is to prepare the data. It is called data preprocessing. Data preprocessing. So the first thing in data preprocessing is to convert data types. As you can see, our diabetes outcome is a numeric, but it's supposed to be a factor. 0, 1, that means it has levels, two levels, which is 0 and 1. 1 means that a person has diabetes, 0 means a person does not have a diabetes. So we convert from numeric to factor. So we click diabetes, diabetes, diabetes $ outcome is equal to as dot factor. This is the function that converts it from numeric to factor. As dot factor, then you repeat again diabetes. That is the name of the data set, $sign that variable, which is outcome. Then you run. After running, you can confirm again using the glimpse function to see if it has changed. As you can see from the output of the glimpse, it means that our outcome now is a factor. Then also, after ensuring that all the data preprocessing bit has been completed, we can implement our logistic regression model. Logistic regression model. Logistic regression model. We just call it model. Model is equals to a logistic regression is a generalized linear model into bracket our study outcome. Then you tilde, full stop, then comma. This means that all the remaining predictors in the dataset will act as independent variables, while outcome will be our dependent variable. So we enter the name of the dataset, which is diabetes. Then we also have to consider family. Remember, these are binary, so family is binomial. Family is binomial of the link logit. Logit link. Link is logit. Then we run. After running, our model has run, we call back the summary of the model. Summary of the model. Summary model. We run the summary of the model. Here is the output of our model. It has estimates, standard errors, z values, and p values. And from our output, we can see that the intercept, the p value of the null model is less than 0.05. It means that the model without predictors is statistically significant. Also, there are p-values for specific predictors, such as pregnancies. Like as we can see here, the p-value for pregnancy, it is less than 0.05. So it means that pregnancies can be used to determine diabetes outcome, or is statistically significant in determining diabetes outcome. As you can also see for glucose, it is showing that the p-value is less than 0.05. So glucose is also statistically significant in determining diabetes outcome. Same to blood pressure, it is also has 1 star. It means that it's also statistically significant in determining the diabetes outcome. Then as for skin thickness, the p-value is above 0.05. It means that skin thickness is not statistically significant in determining the diabetes outcome. As we can see also for insulin, the p-value is also above 0.05. So we can conclude that insulin is not statistically significant in determining the diabetes outcome. Then let's move on to BMI. BMI, the p-value is less than 0.05. This means that BMI is statistically significant in determining the diabetes outcome. Then the last thing we have is diabetes pedigree function. The p-value is also less than 0.05. It means that diabetes pedigree function can be used to predict the diabetes outcome. Then the last predictor is age, which is above 0.05, meaning that age is not statistically significant in predicting the diabetes outcome. Then you can see the model matrix. We can see the null deviance is 993.48. Then the residual deviance is 723.45. So it means that the model with predictors is better than the model without predictors. Then we have also an AIC that is used for comparing of models. So thank you very much. This is all about logistic regression. So let's meet again in our next class. as we handle the linear regression bit. Thank you.